The next part of 3.4 looks at subtracting mixed numbers where you might have to borrow to subtract if you're using method 1. So, for example, just as a recall, if we have this 31 minus 19, so here we're just subtracting whole numbers. Remember, we'd start at the ones column and say we can't subtract 9 from 1. We don't have enough. So we would have gone to the tens column and borrowed 10 by reducing that 3 to a 2, adding a 1 over here. So basically adding 10 to it. So we've got 11 minus 9. Now we can do that for 2. 2 minus 1 gives us 1. So that's similar to how we can do it with mixed numbers. So for example, here we've got 5 3/8 minus 3 3/4. Okay, well, the first thing we're going to want to do is have a common denominator there. And I can see I have a 4 and an 8, and 8 is a multiple of 4. So I'm going to make this denominator 4 into an 8 by multiplying the top and bottom of that fraction by 2. And so now I've got 5 3/8 minus 3 6 over 8. So now I have a common denominator. So if we were using method 1 here, we would start by subtracting the whole numbers. So we have 5 minus 2 to get 2. But then we have 3/8, so plus I'll put here. Then we've got 3/8 minus 6/8. Well, we can no longer do that. We don't have enough. So we have two options here. The option I tend to do is if I see something like this, I'll just do method 2, which is where we converted those original mixed numbers into improper fractions, found a common denominator, and then subtracted them. But the other way you can do it, if you like, is you can borrow. We still have 2 whole of something there. So what we could do is say, well, that whole 2, let's go back a step. So we've got, let's go back here. We've got 5 3/8. Okay, so we could borrow one of those whole numbers. So this would be the same as 4 plus 8 over 8. That's our extra one there. Plus we've got that 3 over 8. And we're taking that and subtracting the 3 6/8. So we could say, well, that's the same as 4 11/8 minus 3 6/8. And now we can do that subtraction. We can do 4 minus 3 to get one whole number. And then we have 11 over 8 minus 6 over 8 to get 5 over 8. So either you can borrow like that, or like I said, we could have converted it into mixed numbers, right? So we've got, I'm going to just do it again over here. We've got 5 3/8 minus 3 3/4. So let's first convert to mixed numbers. So that's going to give us what? 43 over 8. Okay, remember to do the boomerang there. Minus, so 4 times 3 plus 3, so 12 plus 3 is 15, so 15 over 4. Now I need my common denominator, so I'm going to multiply the second fraction by 2 over 2. And so I get 43 over 8 minus 30 over 8. And so I can do that subtraction, 13 over 8, and that would be my final answer, or I could convert to a mixed number, which will give me 1 5/8. So you can see either way, we end up with the same answer at the end. But in the one case, you may have to borrow depending on your numbers. So this is to use either method 1 or 2 to subtract these numbers. So let's start with method 1. So, oh, that's the same as the example, isn't it? 5 3/8 minus 3 3/4. Okay, let's not do that one. Let's skip to the next one because we've already done that one above. Okay, so we've got 9 1/7 minus 4 1/3. So let's start by just trying it with method 1. So I've got 9 and 1/7. Now I know I'm going to need a common denominator there. So I need a common denominator of 7 and 3. 7 and 3 are both prime, which means that the common denominator is going to be their product. So 7 times 3. So the LCD here is going to be 7 times 3, which is 21. So that means I'm going to multiply this first fraction by 3 over 3. to get to 21. And then the second one, I'm going to have to multiply by 7 over 7. So now I've got a common denominator, which is going to be 21. So let's rewrite those as numbers over 21. So I've got 9 and 3 over 21 minus 4 and 7 over 21. And so if we do this method 1, we would go 9 minus 4 is 5. And then we would try to subtract those fractions, and we would say, well, 3 21ths over minus 7 21ths. I can't do that. I don't have enough. So I know I'm going to be borrowing here. So I'm going to rewrite this as 8, and that's going to be plus 21. Maybe I'll just write that in. Plus 21 over 21. That's my extra whole number. Plus I have those 3 over 21s. And then we're going to be subtracting this mixed number here. So that's going to be 8 and 24 over 21 minus 4 and 7 over 21. Now I can do it using method 1 because 8 minus 4 gives me 4. 24 minus 7 gives me 17. So I get 17 over 21. And 17 is prime. 21 is not a multiple, so I know that's in its lowest form. Okay. Maybe what I'll get you to do is pause the video here, try method 1 or method 2. So either borrow or do the improper fractions to do those other two, and then we'll do them together. Okay, let's do these two questions together. So this first one, we've got a whole number. So I'm going to do this with the borrowing method, actually, because it works out quite nicely. So I'm going to rewrite that 7 as 6 5/5 so that I'm able to take away the 2/5 in that next fraction over. Then I can say we've got 6 minus 3 is 3. 5/5 minus 2/5 is 3/5. So you can see the appeal of borrowing. It sometimes makes it quite easy to do a question. Okay, but let's try the next one the other way. So I'm going to do this. I'm going to rewrite that 9 as 9 over 1. And I'm going to convert this to a whole number, or sorry, to an improper fraction. So we've got 7 times 2 is 14. Plus 5 is 19, so 19 over 7. Now we need a common denominator here. So that denominator for 1 and 7 is going to be 7. So I can multiply this first fraction by 7. That's going to give me 63 over 7 minus 19 over 7. Now I've got that common denominator. So we can subtract the numerators. So 63 minus 19 gives me 44. So I have 44 over 7. Or let's do the division to convert that to a mixed number. So 44 divided by 7 goes 6 times for 42. And that leaves me with 2 left over. So my mixed number here would be 7 and, oh, sorry, no, it would be 6. My answer 6 plus my remainder over the divisor. So 6 2/7.